Okay, this video is on loans. So this is something that's probably very familiar to you, specifically the idea of paying back a loan. Okay, so for example, a student loan during college, interest accumulates. You use the compound interest formula to figure that out. But once you get out into the real world and start working, then, well, college is the real world. Once you get out into the professional world and start working, then you have to start paying that back, and you're going to pay a particular amount each month or each year or something like that. Okay? And so we're going to talk about how you can figure out how long it will take you, things like that. Okay? So this is the loan. The idea of a loan, you all know kind of what a loan is, where you borrow money and then pay it back in increments over a particular amount of time. Okay? And so for loans that are paid back in this same way, that are paid back monthly or annually or over a period, each period of time, we use the same formula we did before. So this payout annuity / loans formula, which was, if you remember, P equals D times 1 minus 1 plus R over K to the negative KT all over R over K. So this is the payout annuity loan formula. And we use this because if you think about what a loan for you is a payout annuity for the person who loaned you the money. So if you think about, say you borrowed $20,000 from the bank and you're paying them back a particular amount each month. For the bank, they made an investment in you, and now they're withdrawing a certain amount from that investment each month. So it's the exact same thing, it's just the other side of the picture. And so that's why it's the same formula. The problems work out the exact same way. So say you want to borrow money, you can afford to pay, say, $200 each month, and for, say, 5 years, and they charge you %7 interest. How much can you borrow? Okay, so all of this kind of slots in. We've got $200 each month. That's going to go in for D. We've got our rate. We've got our number of times each year that we're making payments. That's our K. T is the time. And then what it's going to help us figure out is the P. P is going to be the initial amount that you borrowed at the very beginning. Okay? So P is going to be equal to 200 times 1 minus 1 plus 0.07 over 12 to the negative 12 times 5 all over 0.07 divided by 12. Okay? And so to find our answer, we just plug all of that into our calculator. So 200 times 1 minus 1 plus 0.07 over 12 to the negative 12 times 5 divided by 0.07 divided by 12, and we get 10,140 cents. Okay? So you could borrow, if you borrow $10,100.40, and you pay off $200 each month, they're charging you 7% interest for 5 years, you'll pay it off. Okay? So that's a relatively easy example of how this works. Similarly, if you knew how much you wanted to borrow, and we're trying to figure out what the monthly payment were, you would fit in what you were borrowing and then solve for D, just like we did in the last examples. Okay? The other thing that can come up with this, and this is the example I want to work through that's considerably more complicated, is how to use this formula if we're solving for the amount of time. Okay? So let's say, and I'm going to erase the formula, but of course you've got it in your notes by now. So let's say that you borrow $20,000 at 12% interest rate. If you can only pay, say, $400 a month, how long will it take to repay? Okay? Now, a problem like this is more complicated because if you think about what we've got here, we've got our P, 20,000. We've got our D, we're paying $400 each month. 1 minus 1 plus 12% divided by 12 because it's monthly. And then we've got a negative 12t. We don't know t, we don't know time. That's what we're looking for. And so that ends up being, fill in the rest of the formula, finding t ends up being more work because we're now solving for something that's stuck in the exponent. And if you remember from exponential growth, solving for time was harder. We had to use logarithms. It's going to be the same case again here. Okay? So to solve something like this, we're going to do the same thing that we did before. We're going to try and get all of the pieces over to this side until we get just the exponential piece by itself. Then we'll use a logarithm and then solve. Okay? So let's see. I am going to simplify this a little bit first. So 0.12 divided by 12, that's going to be 0.01. One plus 0.12 divided by 12 is going to be 1.01. Okay? So that just makes our lives a little bit easier because now I can take this 0.01 over to the other side. So 20,000 times 0.01 is going to be equal to 400 times 1 minus 1.01 to the negative 12t. And I'm going to simplify these numbers down as we go so that we don't get caught up in it. So 20,000 times 0.01, if you put that into your calculator, that's going to give you, 20,000 times 0.01 is going to give you 200. Okay. We can now take both sides and divide by 400. So 200 divided by 400 equals 1 minus 1.01 to the negative 12t. Similarly, 200 divided by 400 we can simplify down. That's 0.5. We add 1 to each side. Subtract 1 from each side. So minus 1 from this side is going to get rid of this 1. Minus 1 from this side is going to give us negative 0.5. Okay? We can get rid of these minus signs. So divide by negative 1. We'll get rid of the minus sign on each side. We've got 0.5 equals 1.01 to the negative 12t. And now we need to use logarithms. Okay, so remember when we were trying to get something out of the exponent, we had to use a logarithm to get that out. So we've come down to the point where we've got, let me rewrite this, 0.5 equals 1.01 to the negative 12t. and we need to solve for t, we're going to take the logarithm of each side. So log of 0.5 equals log of 1.01 to the negative 12t. And remember, the reason we do that is because once you take the logarithm, the power comes down to a multiple in the front. So log of 0.5 equals negative 12 times t times log of 1.01. So that 12t comes out of the front. And if you want to get t by itself, you're going to have t is equal to log of 0.5 divided by 12, or negative 12 rather, and log of 1.01. Okay, so very similar to what we did with the exponential growth problems. And if you do this, log of 0.5 divided by negative 12 log of 1.01, you get t equals 5.81 years. Okay, so the answer to your question, if you borrow $20,000 at 12% interest and you can only pay back $400 a month, it will take you 5.81 years to pay it back. Okay? The next few videos are examples of problems, just to help you kind of review and see some more examples of this, and then a final video about how do you choose which formula when you're presented with a problem like this.